Carbon is a very abundant element, so it's no wonder it takes so many forms. We're going to explore some allotropes of carbon, which just means the different structures it can take. Diamond, which is made up of carbon, is hard, has a high melting point, and is insoluble, and it doesn't conduct electricity. Diamond is a structure in which each carbon bonds to 4 others, using all of its possible bonds. This creates a regular tetrahedral structure that is very strong. Since all of the bonds are used, there are no available electrons to carry charge. Hence, diamond does not conduct electricity. It has a high melting point, and this is due to the strong covalent bonds between the carbon atoms. You might expect diamond to have similar properties to other allotropes of carbon, but this is not the case. Graphite is another allotrope of carbon, but each carbon is only bonded to 3 others, creating hexagonal pattern. This means that each carbon atom has a spare electron, which creates a sea of delocalized electrons, much like we saw in metallic bonding, which allows graphite to conduct electricity. Due to the forces being weak between the layers, they're able to slide over each other, making graphite a good lubricant in things like bike chain oil. Graphite is insoluble in water, which means it's good for electrolysis electrodes, and it's also very soft. A single layer of graphite is known as graphene. Carbon nanotubes are a type of fullerene. A fullerene can be defined as a hollow carbon structure that forms either a closed cage known as a buckyball or a cylinder. These cylinders are what we know as nanotubes. Carbon nanotubes have a very similar structure to graphene, just in a cylinder as opposed to flat, so it can conduct electricity due to having a sea of delocalized electrons available to carry the charge. They also have a high melting point due to the strong covalent bonds.